Hello everyone and welcome back to my walkthroughs of overthewire.org wargames. In this video I am going to attempt to complete level 17. So I think I have everything set up. So I've got my browser open to level 17. I have burp ready to go. Intercept is off. History is ready to go, and I have my TMUX session open. All right, so let's see what we're looking at here. This looks a lot like, let's just see, is it level 15? Looks a lot like level 15, which was SQL injection. So it was SQL injection, and it was SQL injection with double quotes like level 14. So I'm going to, before I look at the source code, I am going to assume this is in some way the same. So let's start by checking the existence of a username we think exists. So I think that the table structure is the same, which is a table called users with a field called username and another field called password that literally holds the plain text username and the plain text password for that user. And in level 15, we had user Natas 16 existed, and in level 14, I think it was 14, user Natas 15 existed. So I think probably Natas 18 exists. So let's see. Oh, nothing. Okay. Let's try something we think does not exist. Highly unlikely that's a user. In the system, do we get something different? No. Nothing different. Okay. Well, I think this is SQL injection, and I think it is SQL injection with a double quote instead of a single quote. So I'm going to try to break the query. I wonder. So I'm going to go to burp now and look at the responses and see if there's anything in the code comment-wise or if there's anything we're not seeing on the page itself. Coming over here. So let's look at, that's Natas 15, Natas 17. See what just the basic page looks like before we submit any data to it. So what I've learned through this, through level 0 up to now, is that this stuff in the header doesn't seem to be playing any real active role in the war games, and that this statement that they make here at the top, that the stuff in the header has nothing to do with the level, I think that is actually true. So I'm going to come down to the body. So it's just showing us a form. Index.php is where we're submitting to. It's a post. We have a username field and the check existence submit button and the source code. So we could look at the source code, but let's see what we can figure out without doing that. So let's see what we got back. So this would be, which one is this? Okay, this is when I submitted Natas 18 as the username. Let's look at the response. Again, the header doesn't matter. The body is literally empty. Is it going to be empty for the username we think doesn't exist? Is this that request? Yeah. So this is when I submitted that ASDF username. Response. It's exactly the same. So this so far looks like blind SQL injection, but let's see if the error gave us anything different. This may not be SQL injection, just so you know. So the error didn't give us anything either. Or what we think should have been an error didn't give us one. All right, so let's go back. There's one thing I didn't try yet. I actually didn't try this in the others because I didn't have to, because I found SQL injection without it. So time-based SQL injection is where you use a function that causes your query to pause or to sleep in in MySQL, there's a function called sleep. I think there are a couple of others that you can use, but that's the one that I always use when it's available. So let's see. So when username is empty, or is it or it would be or, I think, or sleep. Let's sleep for 5 seconds. I need to close the query because, yeah, I think I need to close that. So I'm saying or here because this portion of the query is probably going to be false, which will make this execute. If I knew this part was going to be true, I could put an and here. Let's find out. Oh, why did that not sleep? Did I do something wrong? Maybe there is no SQL injection. Huh. And it's not right. So I have a space before the comment and a space after. It was the space after was missing the first time I did this. So whenever you close out a query and you put a comment syntax in for MySQL, you need a space after, or it throws an error, I guess. So we have time-based SQL injection, which is interesting. So we can say, let's change this to an and let's put in a username we think does not exist. And this should come back immediately because this portion of my query is going to be false. So it's not even going to bother getting to the sleep part, I think. Yep. And I believe that we can now figure out if Natas 18 is a user in this system. It's taking some time, which means, yes, Natas 18 is a user. Well, it didn't take that long. Let me up that sleep to 8 seconds. Yeah, okay, that's real. So Natas 18 is a legitimate user in the system. Okay, so, but how do I use time-based SQL injection to figure out the password? Let me look at I'm going to look at the source code. So I wasn't going to do that, but I think I need to. Just want to make sure, yeah, so I don't want to waste my time or yours. So create table users, username, password. It's exactly the same as in level 15 and level 14. Same code, if array key exists, username, and our request array. And again, the request array is a predefined PHP array that holds request data that was sent over from the browser. So in this case, username is a form field. It shows up in the request array. If it shows up in the request array, make a connection to the database, select or make a connection to MySQL, and then select the Natas 17 database, build the query, and yes, of course, we have injection. That should be, I mean, I'm going to say it should be filtered, but the reality is PHP has libraries and has code available to use parameterized queries, which is what should be done here. This is bad code. You never drop user provided input directly into your query for precisely the reason we're seeing here. Oh, check it out. I forgot about this. So I can, from level 15, I should have remembered, I can put a debug in my query string. So here is the get array. A get is similar to request. It is a predefined variable in PHP that holds the data that is provided in the query string. So that is anything following the question mark in your URL is your query string. So the get array holds any data in the query string. So we're checking to see if there's a debug variable in the get array. If there is, we're going to print out the query. So that's good. I'm going to use that in just a second. Then we execute our query. We check to see if there are any results. If there are results and the number of rows in the result object are greater than 0, they've commented out the echo statements all the way through. That's why it's blind. So if the user exists, we're not seeing any output. If there are 0 or fewer rows, commented this out, but that means the user doesn't exist, but we're not seeing any output for that either. And this is if there's an error in our SQL. And again, they're not printing that out. So that's why it's blind. All right, so I'm going to go back to the code. I'm going to use this debug to print out my queries using burp. So let's go to intercept. Let's turn intercept on so we can add the get debug parameter. Let's check the existence of this. Debug equals 1. Forward. It's going to sleep. I should have taken that down a notch. Okay, so here's the query. Select star from users where username equals Natas18 and sleep. So if this is true, if this guy is true, and then we also do what follows the and this. So then we do that. If this were false, it would stop at that comparison because one is already false. We don't even need to check the other, right? So how do we use this to figure out the password? If we think back to level 15 and then actually level 16, we know that we can check each character in the password to see what it is. But how do we do that and make use of the sleep function? I'm going to show you. It requires an if statement in our where clause. So we're going to do, you guys hopefully remember this from level 16. If you don't, I will remind you. Binary. Yay. So you probably remember this password like binary character. I'm going to demonstrate what the if does momentarily. Sleep 5. No. Don't forget the space after the comment, and let's check. It should come right back. But I'm going to let me put the debug in here so I can grab this because I'm about to put this in a Python script. All right, so we have select star from users where username equals Natas18 and if password like binary a %, comma sleep 5, comma null. So I'm going to just grab this out. Yeah, so this, right, so this, where we add the comment here, it makes this this double quote be meaningless in the query. So let me grab this guy out and let's go to our command line. So I'm going to copy the 15.py to 17.py. 15.py is a Python script I wrote to figure out the password for level 16. And I'm going to do something extremely similar for level 17. So I want to just go ahead and copy the script. So let's open this up. And before I do anything else, I'm going to paste in the query that I just copied. Okay. And format it so that we can easily see it in a minute when we need it. And all right, so I'm going to come back to that. But first, let's go through and fix what we need to fix. So we're hitting Natas 17 now, not Natas 15. We need to change our authorization value because it will be different. So go to burp, HTTP history, pick any of the Natas 17 requests, and grab out this value here, paste it in, got that, come in. All right, so here's where I need to start making some changes. Turn off intercept. The thing, so in burp, if you have a scope set, so I have put all of my Natas targets in scope, which stops anything else from showing up. So any other pages I hit in my browser while burp is proxying my requests, none of those should show up in my history, and none of them should show up in my sitemap. But they do get intercepted if intercept is on. I'm not sure how to stop that. I have to figure that out. There's probably a way. But anyway, all right, so I'm coming in here and I'm going to just separate this guy out. So this is what we used in level 15. We were just able to, do this because the content differed if we got results back or not. But in the case that we're using right now, we don't get results back, so we can't compare the content to expected results. So, I mean, we could use this, but it would be meaningless because the page would always come back in the same amount of time, essentially, and the content of the page would always be the same. We would see no differences if we do this. So we need to still use, so we're still going to use this condition, but we're going to wrap it in an if right here. See the if. And if this condition is true, right, then we do the first thing in the if. We sleep for 5 seconds. If this condition is false, if A is not the first character, we don't sleep and we return immediately. How do we use this? We are using it with a timeout. So I have timeout set to 3 seconds here. In my query, I'm sleeping for 5 seconds. So this should always time out when this is true, right? So I'm going to need to change a couple of things. The first thing I need to change is I need to set this to Natas 18, and I need to put this in so if password like binary password C, and I need to close that out, comma, sleep, 5, null. There it is. And that should be all. I'm just going to I'm going to comment this out. Python style comments. Okay. So I think that's all we need for the username. I really believe that's the only change we need to make up here in that part. But we do need to change what's happening here. So when this executes and the character is found, this is going to timeout. We are going to get a timeout exception, right? So when we have a timeout, we know we have success. So I'm going to come down here. We don't care about the contents. It never changes. But this is the code we want to use upon success. Actually, I just need to 3DD and then come up here, drop this in. We don't want to print the error. We don't want to exit. We want to return true, right? So I think that's it. I think that's the only change we need. So I'm going to go ahead and run this. If this works, I'm going to wait for it to get the first 4 or 5 characters, and then I'm going to stop the video. Once it gets all the way through 32 characters, I'll come back to the video and I'm going to come and walk through this entire script again from top to bottom. For anyone who missed the walkthrough in 15, or if the walkthrough in 15 wasn't great, I actually think it was not great. I'm new to this whole making videos thing, so learning as I go how to do it. So, all right, let me execute this. Hopefully no typos. I keep having typos, so don't be surprised. Let's see. So we're still on the first character. Looks like we found a lowercase x as our first character. Now we're on the second character in the password. Looks like we found a V for our second character. Now we're looking for the third character. Looks like we found an uppercase K for the third character. And we're going to get the fourth, and then I'm going to pause the video, pause the recording, and come back to this once we get the fourth. Uppercase I for number 4. Okay, so I'll see you guys back here as soon as this is finished running. All right, so I'm back. I actually paused the video and then didn't come back to it until the next morning. So here we are. The script definitely finished. We got this password for what I hope is level 18. So I'm going to copy that out, test it at level 18. Make sure I have intercept off. All right, let's go to level 18. Natas 18, put in our password we think we just got from that script, and it works. All right, awesome. So that worked. That time-based SQL injection definitely got us the password we needed. It was a bit time-consuming, but it worked. So the next thing I'm going to do is walk through the 17.py script, which I pulled from level 15. So anyone who watched me walk through the level 15 script, I would recommend watching this walkthrough again because I think I'm going to do a better, more efficient job of explaining it this pass. All right, so let's jump into that. Clear everything up. All right, so first I'm going to describe the flow of execution, and then I'm going to go through each line and tell you what it does. So when the Python interpreter starts processing a script, it starts from line 1 and it goes through and it does everything that's not in a function first. So everything sort of in the global scope it executes or interprets and then executes. So goes through where it sees variables with an equal sign. Just from a high level, it creates and sets the variable value. If it sees an if statement, it'll go through that. Go ahead and do whatever's within the if the if is true. And then it comes into when it sees function definitions. So here we're defining a function called verify char. It creates this function definition. It doesn't do anything that's inside the definition yet, but it creates the definition. Again, we create another function here called main. So the interpreter is creating this function for us. And then it gets down here to line 78. And it sees this if statement and it will execute the if statement and then do anything. If the if statement is true, it'll do what follows. So in this case, if our variable, and this is a special variable in Python __ name that holds the value of the module being imported or executed. So in this case, we are not importing this script as part of a module. We are executing it standalone. And so when you execute a script standalone, this variable that's highlighted here holds this value. It holds __ main. So if I'm executing this as a standalone script, line 78 will evaluate to true and line 79 will execute. If this script is part of a module that's being imported, this special variable, this special name variable, will hold the name of the module that's being imported. So it won't be main, so this won't execute. If I want to execute in that case, I would say else and then put code here that should run if this is being imported as a module. But we're not doing that. So, all right, so I'm going to go from the top, and now I'm going to walk through program flow. So again, we start at the top. We're importing the ASCII lowercase module from the string library, and this module holds the character set, holds the ASCII lowercase character set. We're doing the same thing on line 2 for the ASCII uppercase character set. On line 3 and 4, we're importing the URL lib request module and the URL lib parse module. The request module allows us to build a request object. The parse module allows us to use that request object in a call to our URL. Line 5 is importing the timeout module from the socket library. The timeout module allows us to check for a timeout on our request, on our URL request. Lines 8 through 15, we are just creating the URL. So the URL protocol is HTTP. The URL itself is that long thing I'm not going to read. And we're not setting a port because it's going to use the default port for HTTP, which is port 80. Then on line 12, I am building the actual URL. So here I'm saying concatenate our protocol, which again is HTTP. Concatenate protocol with :// and then URL at the end. So this plus sign in this case means concatenation because I have a string on either side of it. Then on line 14, if port exists, like if port has a value in it, concatenate : and the port number at the end of the URL string. So you'll notice here I'm wrapping port in the string str function. The str function takes a value and turns it into a string data type. If port, for example, could be, we could have port set to 80, which is an integer. And if I didn't have this string function here, this plus sign would be confused because on the left-hand side we have a string, and on the right-hand side we would have just an integer, and so the plus wouldn't know if it was acting on the string or acting on the integer, if it was doing concatenation or doing math. If I had, let me show you. Num equals 8 plus 9. In this case, that plus sign in here is doing math. So it's adding 8 to 9. If I say num equals 8 plus 9, it's doing concatenation, and num is now going to be 89. Whereas up here, num is going to be 17. So the plus sign decides what it is based on the arguments on the right and left hand side. All right, so hopefully that made sense. Line 17 through 25, I am setting up my headers. So line 18 creates the headers object. Line 19 sets my cookie value if I have one. Line 20 sets my authorization value if I have one, and I do. Line 21 says if I have a cookie value, put that in my header. Line 24 says if I have an authorization value, put that in my header. And then line 27 creates our initial password, which is empty because we don't know what's in it yet. So right now the password variable is empty. And I'm going to walk through, okay, so I'll walk through what's happening in our verify care function. I'm going to take this out so that we can see everything within the function on the screen at the same time. All right, so line 28 starts the definition. Verify char takes two arguments. I'm calling them I and C. Line 29 prints those values out. So it looks like I is an integer, which we know it is, and we're wrapping it in the string function again because we're using it in a concatenation. So I'm printing out I colon space C. Then on line 30, I am using global to bring into scope variables that were set outside the function. Any variable set within the function loses scope once the function leaves. So here on line 31, I'm setting a variable called username. That variable is going to be usable within the function with this value. Once I leave the function, that variable goes out of scope and is probably unset. The value will no longer be this. So when I come back into the function, I have to reset username every time. By using global, I am using the values that are set outside the function to start with. So URL here on line 30 is now going to be equal to whatever URL was by the time I hit line 16. And headers similarly is going to be set to whatever headers got set to in this code. And password is going to be set to what is here. Now, by using global, I'm bringing those into scope within the function. So if I change them within the function, they are changed in the global scope. So we're going to change password inside this function, and that will change. So that's operating on this variable, right? So when I change it in the function, it stays changed even once the function finishes execution, which is important for us to build the password every time we call the function verify char. So that's what line 30 does, and I just explained what line 31 is doing. But let's talk about this piece, concatenating the password variable here. So in our first pass into this function, or our first whatever number of passes into the function that password is empty, it's just going to put an empty string. This is going to be empty, and we're just going to be using the character that's passed in. But as password builds, this is going to be, if password is equaling, I can't remember what the characters were, but let's just say XC4. Then this value here is going to be XC4 plus whatever character I've passed in. So I'm building the password and checking for the next character in the password. I think we all get that piece. I'm going to delete that. Then on line 32, I'm building my post data, which literally at this point is only username. So I'm building that. And here we're using the parse module to encode, to URL encode our post data, and then to encode that as ASCII. Then line 34 says, okay, line 34 says, let's try some things. Line 37 and 41 say, if those things fail, do some stuff. But let's look at what we're trying. So in line 34, we say, let's try to build a request object on line 35. And that request object should use the URL that we pulled into scope here. It should use the post data that we defined here. This is going to change every time. And use the headers data that we pulled into scope here. So build our request object. And then here we're using the request object to open the URL. And we are setting the timeout value to 3 seconds. We'll notice up here in our attempt at time-based SQL injection, we're using 5 seconds for sleep. So the query should sleep for 5 seconds, causing this timeout to occur. Then on line, well, it should sleep for 5 seconds if the password matches, right? So if this character is the next character in the password, we should sleep for 5 seconds, causing this timeout to occur, which then causes line 37 to trigger. We have a timeout exception. What do? We want to concatenate that character onto the end of our password, so our password is building with the correct data in it. We want to print the password out so we can see it, and we want to return true because we've verified that this is the next character in the password. If there are any mistakes or errors in this code, or if the server returns something other than a timeout or a 200, I think that's right. So if the server returns like a 404, I would need to test this. I'm actually not 100% sure. This might, I need to find out what this does. But this is if any other exception is thrown in here, then line 41 executes. So any exception other than the timeout. Line 41 is triggered, and we print the URL, and we print the error that occurred, and we exit. We don't want to continue execution because we have a problem. So we just exit the script at this point. If we get to line 46, lines 35 and 36 executed just fine. There was no timeout, so the character wasn't found, so we want to return false. So that's what verify char does. So understanding that verify char will return true and build onto our password if the character was found, let's look at how we call verify char. So in our main function, which is actually the first thing that gets called, right? So main gets called. We pop in here on line 51. I want to iterate over the code from line 53 to the end of the function 32 times because I'm looking for 32 characters in a password that's 32 characters long, right? So for I in range 1 through 33, so starting at position 1 to position 32, stopping at 33, do these things. Line 53, so line 53 sets a variable called char found to false. I'm using this as a flag to let me know when I need to stop execution of this current iteration of this for loop and move on to the next iteration. I think there's another way to do that. I haven't figured it out, or I haven't really looked into it. And I'm learning Python to some extent still. So line 53 sets this variable. Line 54 says for each character in ASCII lowercase, put that character in variable C. Speaking of scope, so I talked about scope a little bit in the functions. In this case, C is set for this code. I don't know if it's actually available outside of the scope of the for loop. It probably is. But at any rate, I'm setting the variable C here, and I'm using it in my call to verify char. I'm also passing in what iteration, I'm passing in I. So what iteration am I on? What character am I on in my password? And passing in the C from the ASCII lowercase character set. If verify char returns true, this if statement will evaluate to true. I'm setting char found to true, and I'm breaking. And this break on line 57 says break out of the nearest for loop, which is line 54. So I'm breaking out of this for loop. So if varchar returns true on lowercase a, this loop on line 54 only executes once, and then it breaks out after setting char found to true. Then on line 59, I'm checking. Was char found set to true? If it was set to true, then I don't need to continue. I don't need to execute the rest of the code in the for loop. I need to move on to the next iteration of my for loop on line 51. If character wasn't found, then I want to, so the continue statement basically stops execution of the current iteration and moves on to the next iteration of the nearest outer for loop. So if care was not found, I'm going to do the same thing for the uppercase character set. And then I'm going to do the same thing for uh, integers 0 through 9, starting at 0, uh, looping over 10. So 0 through 9 is 10 integers. So we're looping over those by putting the value in that range in the C variable. And I'm passing in C. I'm using the string function here to just pass it in correctly as a string and to verify care. And again, once we find a match, I break out of the loop. And ideally, once we get all the way through our 33 characters, so 1 to 32, we've got a full password, which we saw we did. All right, that's it for level 17. I'll see you in the next video for level 18. Thank you all for watching.